The idea that 20 amp branch circuits are universally required in commercial applications is a misconception not explicitly stated in the National Electrical Code. However, the NEC does stipulate certain requirements for branch circuits in commercial buildings, and these requirements are pertinent to determining the appropriate circuit size for a dedicated appliance, such as a 7 amp freezer. The cornerstone of branch circuit design is NEC section 210.8, which mandates that the ampacity of a branch circuit must equal or exceed the maximum load it is intended to serve. In this context, with a continuous load of 7 amps, a 15 amp branch circuit, employing 14 American wire gauge copper conductors protected by a 15 amp overcurrent protective device, could be considered suitable, provided it complies with all other applicable code requirements. However, several factors must be meticulously evaluated to ensure compliance and safety. Firstly, the nature of the freezer itself and its energy efficiency characteristics play a pivotal role. Freezers, particularly those employing older or less efficient compressor designs, may exhibit significant inrush currents during startup, potentially exceeding the continuous running current by a substantial margin. This inrush current, albeit transient, can place considerable stress on the branch circuit and overcurrent protective device. Therefore, it is imperative to ascertain the freezer's starting current requirements, typically documented on the appliance's nameplate or in the manufacturer's specifications. If the inrush current is deemed excessive, necessitating a higher ampacity circuit to prevent nuisance tripping of the overcurrent protective device, then a 20 amp branch circuit, utilizing 12 American wire gauge copper conductors protected by a 20 amp overcurrent protective device, may be a more prudent choice, even though the continuous running current is only 7 amps. Secondly, it is essential to consider voltage drop within the branch circuit. Excessive voltage drop can impair the performance of the freezer, leading to reduced cooling capacity, increased energy consumption, and potential damage to the compressor motor. NEC section 210.19 provides guidelines for minimizing voltage drop in branch circuits, recommending that the voltage drop should not exceed 3% at the farthest outlet for power, heating, and lighting loads, or a maximum of 5% for the combined feed and branch circuit. To mitigate voltage drop, it may be necessary to increase the conductor size, even if the ampacity of the smaller conductor would otherwise be adequate for the load. Thirdly, local regulations and ordinances may impose additional requirements for branch circuits in commercial buildings, potentially exceeding the minimum standards outlined in the NEC. These local regulations can vary significantly depending on the jurisdiction, and it is crucial to consult with the local authority having jurisdiction to determine if any supplementary requirements apply. Such requirements may include the mandatory use of 20 amp branch circuits for all receptacles in commercial spaces, irrespective of the actual load served, or specific requirements for branch circuits serving refrigeration equipment. Fourthly, the type of wiring method employed for the branch circuit can influence the selection of conductor size. Different wiring methods, such as conduit, cable, or direct burial, have varying ampacity ratings for conductors of the same gauge. NEC Table 310.13b16 provides ampacity ratings for conductors based on their insulation type and the ambient temperature in which they are installed. It is essential to select a wiring method and conductor size that are appropriate for the specific application and environmental conditions. Fifthly, it is imperative to ensure that all electrical equipment and materials used in the installation are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, Intertek, or Canadian Standards Association. Listing and labeling provide assurance that the equipment has been tested and found to comply with applicable safety standards. The use of non-listed or counterfeit electrical equipment can pose a significant safety hazard. Sixthly, the installation must comply with all other applicable requirements of the NEC, including those related to grounding, bonding, overcurrent protection, and wiring methods. A thorough understanding of the NEC is essential for ensuring a safe and code-compliant electrical installation. Additionally, it is prudent to consider future load growth when sizing branch circuits. If there is a reasonable likelihood that the load on the circuit will increase in the future, it may be advisable to install a larger ampacity circuit to accommodate the anticipated increase. This can avoid the need for costly and disruptive upgrades in the future. In general, while a 15 amp branch circuit may appear adequate for a 7 amp freezer in a commercial setting, a comprehensive evaluation of all the factors outlined above is essential to ensure compliance with the NEC and other applicable regulations, as well as to guarantee the safety and reliability of the electrical system. Consulting with a qualified and licensed electrician is strongly recommended to perform this evaluation and to ensure that the installation is performed in a workmanlike manner and in accordance with all applicable codes and standards. Furthermore, the electrician can provide valuable insights into local regulations and best practices, ensuring that the installation is not only code compliant but also optimized for the specific application and environment. Remember that electrical codes are minimum safety standards, and exceeding these standards can often enhance the safety and reliability of the electrical system. For example, using a larger conductor size than required by the NEC can reduce voltage drop and improve energy efficiency. Also, consider using a dedicated circuit for the freezer, even if it is not strictly required by the code. A dedicated circuit can prevent nuisance tripping of the overcurrent protective device due to other loads on the circuit. The NEC also addresses specific requirements for receptacles in commercial kitchens and other areas where food is processed or stored. These requirements may include the use of ground fault circuit interrupter protection for receptacles located near sinks or other wet areas. NEC Section 210.8b outlines the specific requirements for ground fault circuit interrupter protection in commercial locations. Furthermore, the NEC provides guidelines for the proper installation and support of electrical wiring. Wiring must be properly secured to prevent damage and to ensure that it is not subjected to excessive stress. NEC Section 300.4 provides requirements for the protection of conductors and cables from physical damage. In addition to the NEC, other standards and guidelines may be relevant to the installation of electrical equipment in commercial buildings. For example, the National Fire Protection Association publishes NFPA 70E, Standard for Electrical Safety in the Workplace, which provides guidance on safe work practices for qualified electrical workers. Adherence to these standards and guidelines can help to prevent electrical accidents and injuries. When selecting electrical equipment for commercial applications, it is important to choose products that are designed and tested for the intended use. Look for products that are listed and labeled by a recognized testing laboratory and that meet all applicable safety standards. Avoid using substandard or counterfeit electrical equipment, as it can pose a significant safety hazard. Proper maintenance of electrical equipment is also essential for ensuring its safe and reliable operation. Regularly inspect electrical equipment for signs of damage or wear, and replace any damaged or worn components promptly. Keep electrical equipment clean and free of dust and debris, as this can help to prevent overheating and other problems. Follow the manufacturer's recommendations for maintenance and lubrication. In summary, while the NEC does not explicitly mandate the use of 20 amp branch circuits in all commercial applications, a thorough understanding of the NEC and other applicable codes and standards is essential for ensuring a safe and code-compliant electrical installation. Factors such as the type of freezer, its starting current requirements, voltage drop, local regulations, and the type of wiring method employed must be carefully considered. Consulting with a qualified and licensed electrician is strongly recommended to perform this evaluation and to ensure that the installation is performed in a workmanlike manner.